Amidst the vast ocean, a small mollusk, equipped with hundreds of tiny eyes, darts through the water using jet propulsion. The scallop, mysterious in its survival strategies, plays a crucial role in the marine ecosystem and is celebrated as a culinary delicacy across cultures. But how are over 2 million tons of scallops harvested and processed each year before gracing the world's most elegant dining tables? From the icy depths, scallops quietly grow, nestled in fine sand or suspended mid-water on ropes, absorbing nutrients from pristine ocean currents. Once mature, they are hauled from the seafloor and sent directly into advanced processing lines, where they're transformed into plump, succulent morsels known as snow scallops, a name as refined as the product itself. Today, Agriculture Insight invites you inside some of the world's most modern scallop processing facilities to uncover the secrets behind this captivating industry. All will be revealed in this video. If China is considered the scallop processing factory of the world, responsible for over 80% of global exports, then the United States is undoubtedly the most vibrant consumer market, where scallops are hailed as the stars of the seafood table, often fetching premium prices. Unlike other mollusks that passively await their fate, scallops are rare aquatic rebels. They snap their shells to jet across the ocean floor like tiny rockets. Along the edge of their shells, nearly 200 eyes act as a biological radar system, constantly scanning for danger and triggering escape in the blink of an eye. Here's a surprising truth. Scallops, the butter of the ocean that gourmets around the world adore, are often the target of elaborate food fraud. From young shark meat to molded surimi paste, countless imposters can be shaped into what looks like a flawless scallop. But no counterfeit can fool a refined palate. The texture turns mushy, the flavor is bland, and that signature sweetness and aroma are nowhere to be found. Just one bite, and any seasoned diner will know they've just been tricked out of a real taste experience. And every journey has a beginning. Join me as we travel back to the cold, pristine seas, where millions of scallops quietly begin their lives, destined one day to become the highlight of gourmet seafood feasts. The most common method of scallop farming today is the long line suspension technique. Juvenile scallops are attached to long ropes and left to float freely in the clear, open waters. At depths of around 15 meters, hundreds of scallop lines sway gently with the current, forming a vast and untouched underwater farm. For nearly a year, each scallop grows silently in the frigid ocean, absorbing nutrients carried by the currents. No filtration tanks, no metal cages, just the harshness of nature itself shaping sweet, firm, umami-rich meat, one layer at a time. Scallops aren't only suspended in open water, they're also farmed using the bottom seeding method, where juveniles are released directly onto the soft seabed. This technique requires less labor but comes with higher risks. Predators and shifting sediments can threaten the growing scallops. Each farming method has its own strengths and drawbacks, resulting in subtle differences in flavor and texture across scallop varieties. Longline harvesting marks the most rewarding moment of the entire farming cycle. As the hydraulic crane begins hoisting each rope, stretching dozens of meters from the sea, thousands of tightly clustered scallops emerge, clinging like strands of raw ocean pearls, glistening, vibrant, and rich with the taste of the sea. Each heavy rope-laden haul is the culmination of nearly a year of growth amid waves and frigid ocean currents. If longline harvesting is a dazzling performance of living pearl strands suspended in crystal-clear waters, then bottom-seated scallop harvesting is a quiet yet spectacular act of digging gems from the mud. Specialized vessels lower metal dredges, equipped with toothed bars and wheels, to the seabed, then slowly drag them across carefully surveyed terrain. Each gentle sweep lifts the soft sediment layer, revealing scallops hidden below, clinging firmly to the ocean floor. Harvest season typically runs from November to March, when the sea reaches ideal cold temperatures that enhance the scallop's sweetness and firm texture. Each dredging operation lasts only 15 to 30 minutes to minimize impact on the delicate benthic environment. On average, a single haul yields between 500 and 700 kilograms of scallops, depending on sediment thickness and population density. It's an art form, not as forceful as king crab hunting, nor as frantic as anchovy fishing, but slow, steady, and almost meditative, like hand harvesting rice from the depths of the sea. As soon as the dredges and long lines are hauled aboard, thousands of shimmering scallops crowd together in heavy mesh bags. But the journey doesn't end there. On deck, fishermen begin removing the scallops by hand, a process that must be swift yet delicate to avoid cracking the fragile shells. The scallops are then poured into clean seawater troughs for a quick rinse, washing away any remaining sand, silt, or debris from their journey up from the depths. Each batch is scooped out, weighed manually on site, and transferred into specialized plastic containers, clearly labeled with trip details, harvest area, and date. From the deck, these fresh scallops are lifted by crane directly onto refrigerated trucks waiting at the dock. Within hours, they're en route to processing facilities, where a state-of-the-art system begins, preparing these pearls of the sea to grace dining tables around the globe. The scallop cleaning process in factories requires far greater precision than with other mollusks. Due to their deeply ridged shells that easily trap debris, scallops are passed through a high-pressure spray system, reaching up to 5 to 6 bar, strong enough to dislodge embedded sand and silt, yet finely tuned to avoid cracking the shells or harming the live scallops. Unlike oysters or mussels with thick, robust shells, scallops are more delicate and prone to damage, making every second of water pressure a calculated balance. This stage is both a science and an art, ensuring absolute cleanliness while preserving the scallop's freshness and structural integrity. After being thoroughly cleaned, scallops move on to the shelling stage, where precision and speed must work hand in hand to preserve the delicate, sweet meat inside. This is one of the most critical manual steps, requiring human skill that surpasses even machinery. Unlike oysters or clams, which need to be briefly boiled to open, scallops have relatively weak adductor muscles. This allows workers to open them alive using specialized knives, a method that retains freshness while quickly separating the prized white adductor muscle from the viscera and membranes. In many Japanese processing plants, trained technicians can open up to 1,200 to 1,500 scallops per hour, achieving both speed and aesthetic precision. Live shelling preserves the scallop's natural flavor and intact texture, a crucial requirement for premium export markets like the US and Europe. This isn't just processing, it's the art of carving pearls inside the factory. Yet despite its elegance, the task carries risks. Hard shells, sharp blades, and slippery hands mean that even a small mistake can cause injury. That's why workers must wear full protective gear and operate with extreme care at all times. In modern processing facilities, the shelling of scallops is now supported by automated machinery, easing the burden on workers while maintaining both speed and precision. Workers simply place each scallop onto a conveyor belt. The rest is handled almost entirely by the machine. A mechanical arm holds the shell firmly in place while a thin blade glides along the edge, swiftly splitting it open. The white adductor muscle, known as the scallop meat, is then neatly extracted, while the shells and viscera are separated into designated trays. On average, such a line can process between 8,000 and 10,000 scallops per hour, with an exceptionally low error rate. Compared to manual methods, this system delivers more consistent results, improved hygiene, and is perfectly suited for the stringent standards of export markets. After shelling, The ivory white scallop adductor muscles, the most prized part, move on to a final cleaning stage. A gentle high-pressure spray system, combined with aerated water baths, removes any remaining impurities such as shell fragments, membrane strands, or fine sediment. Even after careful processing, tens of thousands of scallops are inspected and meticulously rinsed every hour to ensure each piece meets an almost immaculate level of cleanliness. This step is also what elevates the product to sashimi grade, fresh and clean enough to be consumed raw immediately after thawing. In the scallop processing industry, cleanliness is more than just a standard. It's a matter of pride, of quality, and the key to preserving the highest market value on the global stage. Once cleaned and sorted, fresh scallops are packed directly into specialized plastic containers under chilled conditions. Workers, equipped with protective clothing and sterile gloves, carefully arrange each scallop to preserve its freshness and avoid damage. The containers are then sealed, labeled with traceability information, and stored at 0 to 4 degrees Celsius, ready to be delivered to restaurants, supermarkets, or processing facilities within a short time. This method is commonly used for packaging fresh scallops intended for local markets or short-distance transport. After being thoroughly cleaned and inspected, the ivory white scallop adductor muscles are fed into an automated sorting system, where each piece is evaluated based on size, color, and meat quality. Only those meeting the highest standards proceed to one of the most critical stages in the processing chain: ultra-fast freezing. In this stage, the temperature is rapidly lowered to 40 degrees Celsius within just a few minutes. This sudden freezing process locks in the scallop's original freshness, preserves its firm texture, natural flavor, and nutritional content. At the same time, it forms ultra-fine ice crystals, minimizing tissue damage and preventing moisture loss during thawing, a key requirement for sashimi-grade products. Immediately after freezing, the scallops are transferred to the sorting and packaging system. Here, each piece is automatically scanned and classified by size or weight with high precision. Qualified meats are then portioned by electronic scales, packed into vacuum-sealed pouches or trays, and labeled with full traceability information. After being removed from the shell and cleaned, the adductor muscles are briefly blanched in hot water to eliminate any odor, kill bacteria, and retain the necessary firmness. This crucial step helps the scallop meat maintain its beautiful color and structure before entering the drying process. Next, the ivory white scallop meat is either sun-dried naturally or heat-dried in a controlled environment. This process can last from several days to a week, depending on weather conditions and the thickness of the meat. During this time, moisture gradually evaporates, causing the scallop meat to shrink into cylindrical shapes, turn a golden brown color, and emit a rich, distinctive aroma typical of high-quality dried seafood. Once the ideal level of dryness is achieved, the scallops are sorted, packaged, and stored carefully. The final product retains a deep sweetness, high umami, and is a premium ingredient in dishes like porridge, soups, or gourmet seafood broths. Behind the multi-billion-dollar scallop industry lies an invisible mountain. Millions of tons of discarded shells left behind after processing. In Japan alone, more than 200,000 tons of scallop shells are generated annually. Without proper treatment, they pose a serious threat to both marine and terrestrial environments. But rather than treating them as waste, the Japanese have transformed these shells into a valuable resource. Through fine grinding and high-temperature recycling technologies, scallop shells are turned into bio-based materials used to produce helmets, construction bricks, wall paint, and even calcium-rich animal feed. In regions like Hokkaido, local governments have partnered with design companies to create eco-friendly insulation materials, contributing to a green circular economy, where not only the scallop meat, but even its shell is reborn with new value. This is more than just a technological advancement. It's a testament to Japan's masterful approach to sustainable thinking. The journey of the scallop ends with tender, flavorful slices full of refinement. But this is just a small glimpse into the vast world of food. Countless fascinating stories are still waiting to be uncovered. Let's continue the journey to discover what lies ahead. Before becoming food, mussels are the silent gatekeepers of marine ecosystems, helping purify the water and sustain life beneath the ocean's surface. Today, mussel farms stretch across Europe, South America, and Asia, with global production exceeding 1.8 million tons annually, supporting an industry valued at around $5 billion USD. Chile, China, and Spain currently lead the world in mussel farming, thanks to their ideal marine conditions and advanced aquaculture technologies. Compared to other seafood like shrimp or salmon, which often require industrial feed and generate high emissions, mussels stand out for their ultra-low carbon footprint, while still being rich in protein, omega-3s, and essential minerals. They've become a symbol of sustainable nutrition in an era where humanity seeks balance between health and the environment. Right now, let's head to pristine coastal waters to see how farmers harvest thousands of mussels each day, kicking off their remarkable journey from ocean to table. There are 4 main mussel species farmed worldwide, each adapted to different marine environments and cultivation methods. Among them, the European blue mussel and the New Zealand green-lipped mussel stand out for their high meat quality and significant commercial value. In Chile, China, Spain, New Zealand, and other regions with deep, clean waters, the long line, suspended rope method is the most commonly used. It offers low costs, scalability, and high efficiency. Depending on the farming region, mussels are typically harvested from late winter to mid-summer when they reach optimal size and nutrient content. The harvesting process begins by lifting the mussel ropes out of the water using hydraulic cranes or specialized pulley systems. Each rope can reach 15 to 20 meters in length, weigh hundreds of kilograms, and be covered with thousands of mussels clumped together in large, dark clusters, along with seaweed and other marine organisms. So how do farmers separate thousands of mussels from these thick, anchor-like ropes? Traditionally, mussels were removed by hand. Farmers used scrapers, wire brushes, or metal combs to gently rake along the ropes, dislodging the mussels into collection trays or tanks. While simple, this method is time-consuming, labor-intensive, and can damage the mussels if not done carefully. Moreover, freshly harvested mussels are often covered in mud, dead barnacles, seaweed, and other biofouling organisms, so a pre-wash system is typically installed on board to rinse off the debris and ease the burden on processing plants. In modern mussel farms, this manual process has been replaced by automated onboard mussel stripping machines. These systems use rotating drums, metal rods, or stiff brushes, combined with high-pressure seawater jets, to gently shake and scrub the mussels off the ropes. The mussels are then filtered and collected in storage bins. This automation allows for faster, cleaner harvesting and significantly reduces mechanical damage compared to manual handling. Immediately after detachment, the mussels are sent through a seawater rinse conveyor to remove remaining sand, mud, and fouling organisms. Some vessels are even equipped with aeration units or coarse filters to further enhance hygiene before storage. Meanwhile, in parts of Europe, especially coastal regions of France, the Netherlands, and Belgium, mussels are farmed using the bouchot method, where they naturally attach themselves to vertical wooden poles fixed into the seabed. When the tide rises, the mussels are submerged in water to feed and grow. When the tide recedes, parts of the poles become exposed, allowing farmers to observe the mussels and time the harvest more precisely. Unlike suspended rope systems, the Busho method doesn't allow for harvesting with pulleys or rotary strippers. Instead, farmers use specialized harvesting boats equipped with hydraulic cranes and custom mussel scraping buckets. These buckets are lowered close to the poles and operate like automated brushes, dislodging mussels from the wood surface while simultaneously washing away mud and debris with integrated water jets. Once dislodged, the mussels are suctioned into a collection chamber and transferred into the boat's storage hold. This approach speeds up the harvesting process, reduces manual labor, and minimizes the risk of breaking the poles or damaging the mussels, which can happen with traditional hand harvesting methods. After each harvest season, Busho mussel farms require thorough cleaning and maintenance to prepare for the next cycle. The horizontal ropes stretched between poles, typically used to stabilize young mussels during early attachment, are removed, cleaned, or replaced if damaged. At the same time, the wooden Busho poles are carefully inspected and cleaned to remove barnacles, seaweed, and other fouling organisms, ensuring a clean surface for the next generation of mussels to attach. In some regions, farmers also rotate or replace older poles to maintain structural integrity and reduce the risk of breakage or rot caused by prolonged exposure to salt water. All of this maintenance work must be carried out during low tide, requiring technical skill, physical effort, and seamless coordination between human labor and machinery. Once harvested, fresh mussels are transported to the processing plant in insulated containers and temporarily stored in aerated, artificial seawater tanks. This system keeps the mussels alive and healthy while allowing them to expel sand and grit before processing. As a result, the raw materials remain fresh and ready for the production line at any time. To begin processing, the mussels are poured into a feeding hopper and enter a fully automated closed-loop cleaning system. This integrated line includes pre-washing, beard removal, and drying, ensuring each mussel is thoroughly cleaned before further processing. First, the mussels slide into a pre-washed trough, where high-powered water jets remove dirt, seaweed, and coarse debris. Some facilities use rotating drum washers equipped with stiff bristled brushes, which tumble the mussels continuously in a spinning chamber while brushing them from multiple angles. Next, the mussels are directed into the central processing chamber, where rotating brush systems scrub the shells and pull off the byssal threads, beards. Throughout the process, low-pressure water sprays maintain moisture and immediately rinse away loosened debris. Finally, the mussels are transferred to a round bar vibrating conveyor, which gently shakes off excess water and dries the product. The vibration also helps separate mussels stuck together or those with residual beards. Thanks to the synchronized action of water, brushes, and mechanical motion, this automated system can clean several tons of mussels per hour, significantly reducing labor costs and processing time, while ensuring consistent quality across every batch of raw material. A conveyor belt with workers stationed alongside awaits just after the cleaning process is completed. Here, the mussels are carefully inspected by hand, with broken shells, dead specimens, mussels with residual debris, or those not fully debearded being manually removed. Although most of the process is automated, it is the eyes and experience of human workers that serve as the final layer of quality control, ensuring that only the best mussels continue to the next processing stages. The conveyor then carries the selected mussels to the packaging area. At the end of the line, mussels slide into a sorting funnel, where the product flow is evenly distributed into mesh bags or specialized sacks below. An automatic weighing system precisely controls the contents of each bag, typically between 1 and 2 kilograms, before the bags are securely sealed using plastic rings or specialized ties. In addition to mesh bags, plastic tray packaging is another preferred option for premium retail markets and restaurants where visual presentation matters. In the tray packing area, mussels are evenly arranged into pre-formed plastic trays in fixed quantities. The trays are then sealed with clear shrink film by an automated machine to ensure hygiene and preserve moisture. Finally, each tray is labeled with complete product information before being sent to chilling and boxing stations. A popular product line in mussel processing is frozen half-shell cooked mussels, commonly supplied to supermarkets and high-end restaurants. After thorough cleaning, the mussels are steam-cooked at low pressure at 95 to 100 degrees Celsius, allowing the meat to be gently pre-cooked and loosened from the shell without damaging its structure. Once steamed, the mussels move along a cooling conveyor, where workers inspect and remove any defective ones. Next, one half of the shell is removed using specialized knives, creating the visually appealing and convenient half-shell mussel product. This step requires skilled hands to preserve the shape and keep the meat firmly attached to the remaining shell. Following this, the mussels are placed into aerated cold water tanks to rinse off shell fragments, quickly lower the temperature, and firm up the meat texture. They are then evenly spread onto a blast freezer conveyor set at -35 degrees Celsius, ensuring each mussel is individually frozen, locking in color, texture, and extending shelf life up to 18 months. Finally, the frozen mussels are automatically portioned into 250 grams to 1 kilogram flexible plastic bags, sealed, packed into labeled cartons, and stored at -18 degrees Celsius. The finished product is ready for distribution to supermarkets, restaurants, and global export markets. Have you ever wondered how humans are able to produce thousands of tons of black pearls of the ocean from such tiny creatures? The journey of mussel farming begins at coastal hatcheries or laboratories, where young mussels, known as spat, are cultivated from wild-collected larvae or through controlled artificial spawning. By adjusting water temperature, salinity, or light, technicians stimulate mature mussels to reproduce. Once eggs and sperm are released, fertilization takes place in incubation tanks, and within 24 hours, they develop into trochophore larvae. Over the next 2 to 3 weeks, the larvae continue to grow while feeding on microalgae in nutrient-rich seawater. Upon reaching the petavillager stage, they begin searching for surfaces to attach to and secrete byssus threads, strong biological fibers that allow them to anchor tightly onto ropes, wooden slats, or mesh substrates in the tanks. With the bouchotte method, a traditional mussel farming technique practiced in France and parts of Europe, the preparation of the farming area plays a crucial role. Farmers must select wide tidal flats with flat seabeds, firm ground free of silt, and regular tidal movements. During the low water season, thousands of wooden poles, each 3 to 5 meters long, are driven vertically into the seabed in neat, straight rows, forming biological walls ready to receive mussel spat. Ropes or mesh are often strung horizontally between the poles to increase the surface area for attachment and prevent mussels from being dislodged by waves. Mussel-laden ropes, already seeded with juvenile mussels, are then wrapped in a spiral around each pole and securely fastened, ensuring stable growth when the tide rises and submerges the farm. This entire process requires not only mechanical support, but also the farmer's experience in timing the tides, determining water depth, wind direction, and spacing of the poles. If placed too densely, the flow of water is restricted; too sparsely, and productivity drops. Once everything is in place, the mussels begin their growth journey in natural seawater, feeding on plankton and gradually forming dense clusters tightly attached to the wooden posts. If Norway is considered the salmon capital of Europe, producing a staggering 55% of the world's farmed salmon, with massive sea farms spanning hundreds of hectares in icy waters year-round, then the United States is the most advanced salmon processing powerhouse on the planet, where high-tech factories from Alaska to Maine operate around the clock, shaping the global salmon supply chain. Tuna often appears in everyday meals, from sushi to convenient canned products, known for its rich flavor and firm, meaty texture. Salmon, on the other hand, is celebrated for its exceptionally high omega-3 content, buttery soft flesh, and remarkably low mercury levels, making it a safe and nutritious choice for both young children and pregnant women. Salmon around the world mainly comes from two sources, wild and farmed, with over 70% of current production originating from coastal farms in cold water regions. Wild salmon travel thousands of kilometers to spawn before ending their life cycle, while farmed salmon are raised under conditions as precise as a laboratory. Two very different journeys, yet both contribute to the creation of a global culinary icon. Every August, when salmon fishing season reaches its peak, the waters off Nolesen come alive. Fishing fleets line up, slicing through the waves in search of what many call the silver treasure of the sea. When the radar detects a school of salmon beneath the icy surface, the crew springs into action, deploying massive nets that form a wide arc, slowly tightening to trap the entire shoal in a giant pocket. A single haul can bring in up to 20 tons of salmon, nearly 40,000 fish thrashing in the morning light, spraying water across the deck like a shimmering storm. The ship vibrates with life, rumbling engines, rushing water, shouting crew, all blending into a floating factory at sea. To preserve freshness, the fish are immediately transferred to chilling holds kept near 0 degrees Celsius, slowing biological breakdown and locking in texture and color for hours at sea. Once ashore, these silvery harvests continue their journey to cutting-edge processing plants. For top-grade salmon, destined for sashimi, worth tens of thousands of dollars per ton, the journey may take to the skies. Some shipments fly direct from Norway to Tokyo within 36 hours, arriving just in time to please even the most demanding sushi connoisseurs. However, faced with an increasingly brutal journey of survival, salmon have gradually been guided by humans into farms, through artificial waterways engineered to replace the wild. Each spawning season, they leave the ocean and swim thousands of kilometers upstream to return to the very river where they were born. They battle fierce currents, leap over roaring waterfalls, all to complete their life cycle. But nature has never been gentle on this journey. As they leap up waterfalls, they often come face to face with the infamous brown bears, patient predators lurking at the base, waiting to strike the moment a fish breaks the water's surface. Those that survive it all, the female digs a nest in the cold gravel, the male fertilizes the eggs, and both die in exhaustion. Though each fish can lay thousands of eggs, nature is unforgiving. Only about 1 in 1,000 offspring survive, grow, and are lucky enough to return to the sea and continue the cycle. That's why humans have created an alternative path, where nature is recreated through high technology. In freshwater zones near estuaries, dams and artificial fish ladders not only help the salmon bypass obstacles, but also serve as checkpoints for health and behavioral monitoring. The strongest fish are selected and transferred to specialized tanks, where every condition, from temperature and oxygen to water flow, is precisely controlled, preparing them for the most crucial phase, the collection of eggs and milt, launching a new life cycle under human guidance. In the wild, salmon fertilization is a fierce battle among males, a tense showdown where only the strongest wins. But in fish farms, the process is far more gentle. The only thing the salmon have lost is the chance to choose their own mate. The female is placed on a processing table, where a gentle incision reveals rows of plump, amber-colored eggs, neatly aligned like strands of deep-sea pearls. Depending on the species and size, each fish carries between 2,000 and 10,000 eggs. At the same time, the males are handled with care to extract their milt. Within just 30 to 60 seconds after the eggs are harvested, the sperm must be mixed immediately in a clean, clear tray, free from blood or impurities, as even a single drop can ruin an entire batch. If delayed, the eggs will dry out and lose their ability to be fertilized. While in nature, less than 1% of fertilized salmon eggs survive, in the controlled environment of a hatchery, that success rate can reach up to 90%. The fertilized eggs are immediately transferred into specialized incubation trays, placed within a flowing water system that gently mimics the cool, clear streams where salmon were once born. The water temperature is carefully maintained between 10 to 12 degrees Celsius, refreshingly cold and crystal clear, just enough to awaken the dormant spark of life within each fragile shell. After about 2 weeks, tiny eyes begin to appear inside the eggs, a subtle yet miraculous sign that life is slowly awakening. Around day 45 to 60, the young salmon break free from their shells, entering the sac fry stage, carrying a yolk sac under their belly that sustains them through their first few weeks without the need for food. Once the yolk is absorbed, they transition into the fry stage, where they begin swimming, feeding, and adapting to the flow of water. They are then moved to larger rearing tanks, where every environmental factor is carefully controlled. When they reach about 5 centimeters in length, they're known as fingerlings, still small, but already bearing the shape of mature salmon. At this stage, the process of saltwater acclimation begins. Salt is gradually added to the water, like a gentle reminder of the vast ocean that awaits them. As young salmon grow and begin to take on the distinct shape of a migratory fish, they are moved to brackish water areas near river mouths, a natural transitional environment where fresh water mixes with saltwater, helping them adapt more easily. Salmon are such voracious eaters that they almost never turn down a meal. Their daily diet consists of compact, nutrient-rich pellets, made from fish meal, fish oil, soy, and various minerals. Each pellet is packed with everything the fish need to grow quickly and develop that signature reddish-orange flesh. On average, each salmon pen consumes around 2 tons of feed per day. Notably, feed accounts for 50 to 70% of the total cost of salmon farming, making portion control a critical factor for every farm. Even a small miscalculation in daily feed allocation can result in financial discrepancies of tens of thousands of dollars each month. Unlike wild salmon harvesting, which depends on migration seasons and open sea fishing, farmed salmon can be harvested in a much more controlled and proactive manner. Once they reach the ideal weight, typically between 4 and 5 kilograms, the fish are guided into an automated grading system to check their size and health condition. Qualified individuals are then pumped directly onto harvesting boats or transferred to onshore processing facilities. The entire process follows a fixed schedule, ensuring a stable, year-round supply without relying on nature's timing. And now, let's step inside the processing plant, the moment we've all been waiting for, where thousands of fully grown salmon are turned into premium food products. Before being filleted, female salmon are carefully examined to harvest their eggs, a key ingredient used in the production of premium caviar. After being extracted from the fish, the roe is transferred to a specialized washing system to remove blood, membranes, and impurities. Ultra-fine spray nozzles gently clean off the outer mucus without damaging the delicate membrane of each egg. The salmon roe is then transferred to brining tanks, where a salt solution is gently stirred by soft paddles in a steady circular motion, allowing the salt to evenly penetrate each egg. Salinity, temperature, and timing are strictly controlled to firm up the eggs, bring out a beautiful amber hue, and preserve their naturally rich, briny flavor. Once brining is complete, the roe moves to the final inspection station, where bright white lighting helps technicians detect any broken, cloudy, or underperforming eggs. The final product, shimmering, salted pearls, is portioned into specialized tins by automated dosing machines, packed precisely in 200 or 500 grams. Then the tins are chilled and neatly stored, ready to deliver a taste of the ocean to dining tables around the world. And the journey still doesn't end there. Entering the filleting stage, the pinnacle of salmon processing, each fully grown fish is passed through a modern fillet machine. High-speed rotating blades simultaneously remove the backbone and split the fish into two symmetrical halves, all while preserving the freshness and integrity of each muscle fiber. For smoked salmon products, the skin is intentionally kept, acting as a natural shield for the meat in the steps that follow. Next, an automatic bone removal system takes over, using ultra-precise clamps to extract any remaining pin bones. The fillets are then scanned by optical sensors that assess color, freshness, and texture. Any pieces that don't meet the standards are instantly removed from the line. Yet few people realize that the vibrant orange color often seen isn't natural. Freshly caught salmon usually has pale pink or deep red flesh. To achieve that eye-catching hue, many factories use carbon monoxide gas, an industrial makeup that keeps the fish looking fresh long after processing. So the real question is, how can you tell if a piece of salmon is truly fresh and not just fresh-looking? At this stage, the salmon is ready to enter the smoking line, the final step where raw fish is transformed into one of the most refined delicacies ever crafted from the ocean. It all begins with salting, a process that may seem simple, yet plays a decisive role in shaping the final flavor. There are two common methods: dry curing, where fine salt is evenly sprinkled over the surface of the fish, allowing its natural moisture to draw the salt inward, and wet brining, where the fillets are soaked in a saltwater solution, typically containing 3 to 5% salt, depending on the desired curing time. Both techniques aim for the same result: to reduce moisture, enhance the natural saltiness, and build a flavorful foundation for smoke to cling to and penetrate deep into the flesh. Once ready, the fish is placed on trays or hung on metal racks inside the smokehouse. Oak, maple, or cherry wood is gently smoldered, releasing thin, warm streams of smoke that weave through each fillet, infusing it with the subtle aroma of both wood and thyme. Depending on the intended product, smoking can last anywhere from 4 hours for a lighter flavor to 24 hours for a richer, deeper profile. With smoked salmon, thyme is the secret seasoning, a slow and deliberate process where technique, ingredients, and human intuition blend together to create a dish that carries not just flavor, but traces of fire, smoke, and memory. When the smoking process comes to an end, the salmon has fully absorbed the essence of fire and wood, ready to enter its final stage: packaging. Each slice is placed into a vacuum sealing system, where all air is removed to preserve its moisture, texture, and the delicate smokiness that has gently permeated the flesh. From chilly processing facilities in the far north, smoked salmon begins its journey, traveling thousands of kilometers to reach dining tables in Tokyo, Paris, or New York. It's more than just food. It's a culinary voyage, carrying with it the essence of the sea, the warmth of wood smoke, and the craftsmanship of human hands. Gone are the days when farmers had to cut rice by hand with sickles and spend days processing it manually. Rice harvesting in the U.S. has evolved into a highly mechanized and efficient process, primarily using combine harvesters, large and powerful machines that can complete in minutes what previously took farmers days to accomplish. These machines not only cut the rice, but also thresh, separate, and clean the grains in a single operation, making them indispensable in modern rice farming. The introduction of combine harvesters has dramatically transformed rice production, increasing efficiency, reducing reliance on manual labor, and ensuring that rice can be harvested quickly before adverse weather conditions impact the yield. A combine harvester is a sophisticated piece of machinery with multiple essential components, each serving a specific purpose to ensure a seamless harvesting process. At the front of the machine is the header, a critical attachment responsible for cutting the rice stalks and feeding them into the harvester. As the stalks are drawn in, they enter the threshing drum, which plays a key role in separating the grains from the stalks and husks. This stage is crucial, as it allows the grains to be detached efficiently without damaging them, ensuring the maximum yield from each field. Once the grains have been separated, they pass through sieves and a cleaning system, where any remaining debris, broken husks, or unwanted materials are filtered out, leaving behind clean, high-quality rice. This meticulous process ensures that only the best grains proceed to the next stage. The harvested rice is then stored in a grain tank, which temporarily holds the rice before it is unloaded into waiting trailers or trucks. This unloading system allows for a continuous harvesting flow, ensuring that fields can be cleared efficiently and promptly transported to processing facilities. One of the most significant advantages of using combine harvesters is their ability to increase harvesting efficiency by up to 50 times compared to traditional manual methods. This dramatic improvement not only saves farmers time, but also reduces labor costs and minimizes grain loss. With rice being such a vital staple food, the ability to harvest quickly and efficiently ensures that more rice reaches processing plants, meeting the demands of both domestic and international markets. The integration of industrial machinery into rice farming has revolutionized the industry, making large-scale production feasible while maintaining high standards of quality. In addition to efficiency, modern combine harvesters incorporate advanced technologies that optimize yield while minimizing environmental impact. Many of these machines are now equipped with GPS tracking systems, which enable farmers to precisely map their fields and follow optimized harvesting patterns. This precision reduces waste, prevents overharvesting in certain areas, and maximizes the use of available land. Furthermore, many combine harvesters feature adjustable cutting heights and grain loss sensors, ensuring that every stalk of rice is harvested effectively while reducing unnecessary waste. Beyond their immediate harvesting capabilities, combine harvesters also contribute to sustainability in agriculture. By streamlining operations and reducing the need for extensive manual labor, these machines allow for more controlled water and soil management, ensuring that rice paddies remain fertile for future planting seasons. With innovations such as automated moisture detection systems, farmers can make informed decisions on the best times to harvest, preventing spoilage and maximizing the longevity of their crops. The adoption of such cutting-edge technology continues to push the boundaries of agricultural efficiency, positioning U.S. rice farming as a model of innovation and sustainability. In an era where global food demand is increasing, the ability to produce rice efficiently while conserving resources is more critical than ever. Farmers who incorporate these advanced techniques not only improve their own profitability, but also contribute to a stable and sustainable global food supply. Once rice is harvested, it doesn't go straight to store shelves. Instead, it undergoes several processing steps in factories to make it safe and appealing for consumers. The first step in processing is cleaning and drying. Freshly harvested rice contains moisture and impurities like dirt, stones, and husks. Large industrial dryers reduce moisture levels to prevent spoilage. The drying process is crucial because improperly dried rice can develop mold or spoil before it reaches consumers. After drying, the next step is hulling, where the outer husk is removed, leaving behind brown rice. For those who prefer white rice, the process continues with milling, where the bran layer is polished off, revealing the soft white grains underneath. This process is done carefully to ensure that the grains remain intact and maintain their quality. However, milling reduces the nutritional content of the rice, which is why some manufacturers enrich white rice with vitamins and minerals before packaging. The next crucial step is sorting and grading, where high-tech machines use lasers and sensors to remove broken or discolored grains, ensuring uniformity. This step ensures that only high-quality rice makes it to consumers. Finally, the rice is packaged and stored in temperature-controlled warehouses before being distributed to markets. Some rice is processed further into rice flour, rice bran oil, or instant rice products to meet the diverse needs of consumers. Factory processing ensures consistency, food safety, and efficiency in the supply chain. With rigorous quality control measures in place, American rice producers can guarantee that their products meet both domestic and international food safety standards. This level of precision ensures that the rice sold in stores remains fresh, nutritious, and free of contaminants.